Welcome to all on my YouTube channel Mathematics with Sachin. This is lecture series on replacement problems, and this is the seventh lecture on this replacement problem. In this lecture, we discuss examples on replacement problem with money value, which includes money value. In previous lecture, sixth lecture, we discuss theoretical part corresponding to these replacement problems with money value. Now we have to use that theoretical concept in solving these examples on these replacement problems. We take first example as assume that present value of 1 rupee to be spent in years time is rupees 0.90 and the purchase price is A is equals to rupees 300. The running cost of the equipment is given in the table below. When should be the machine replaced? When should the machine replace? We have to given the corresponding running cost. First year 500, second year 600, third year 800, fourth year 1000, fifth year 1300, sixth year 1600, and seventh year 2000. These are the given running cost corresponding to that particular equipment or machine. And we have to find out the best age of replacement of the machine. Okay, for that first we have to write down the given data and perform a table to find out the best age of replacement. We have to given here the cost of machine C or A is equals to rupees 3000. Also given that the discounted rate per year gamma is equals to 0.9, and we compute a table as follows. This is the table. It contains 8 columns. First column gives n, defines n. N means the number of year. This gives the number of year. This represents the number of years. Rn are the maintenance cost or running costs. Gamma raised to n minus 1. We have a discounted rate or present worth factor, that is gamma. The value of gamma raised to n minus 1 we have to write here. As n changes, the value of this gamma raised to n minus 1 will also changes. Then to find the calculations, we have to multiply these two, Rn and gamma raised to n minus 1, and that we have to define a new column. Then we have to add these in each and every year corresponding to the previous years, and we have to find out the summation Rn gamma raised to n minus 1. And then we add this sum to the total cost or cost of the machine C, then we get the value of f of n. Then also we have to find out the summation gamma raised to n minus 1. We have a column for gamma raised to n minus 1, and we have to add this quantity with this quantity each and every term. This quantity will add to this, and we get this column. And this last column gives the average cost of the machine, and for that we have to divide this fn by summation gamma raised to n minus 1. In previous lecture we have to derive a theoretical part, and in that theoretical part the average cost is fn divided by summation gamma raised to n minus 1. If you remember, in that fn can be written as C plus R1 plus R2 gamma plus R3 gamma square and so on, Rn gamma raised to n minus 1 divided by 1 plus gamma square plus gamma cube up to gamma raised to n minus 1. And that formula will be converted in this format, that is numerator becomes fn, which is defined here, and denominator becomes summation gamma raised to n minus 1. Therefore, now these are the 8 columns, and now we have to fill up this table for using some calculations. First, we have to given this maintenance cost for each and every year. First, we have to write down this maintenance cost. Up to 7th year, we have to given a data. So, we have to prepare a table up to 7th year. So, these are the maintenance costs corresponding to that year. Now, we have to calculate each and every value. At the start, when in the first year, n is equals to 1. Therefore, gamma raised to 1 minus 1 means gamma raised to 0. Here value of gamma is 0.9. 0.9 raised to 0 means something raised to 0 gives 1. So this value will be the 1. Now we multiply this to 500. We get this Rn into gamma raised to n minus 1. That is 500. Then we have to add. This is the first value. So that value will be the here. No any addition. That value will continue this. Then we have to add this summation, a cost of the machine. The cost of machine is 3000. So we add 3000 to this 500. We get 3500. Then gamma raised to n plus 1. It is the first year. So this value will carry forward here, and we get it is equals to 1. And obviously average cost, we have to divide this. We have to divide 3500 by 1. Obviously we get 3500, the total value of average cost. Now come to the second year. In the first year, mostly the values will be the remains same in this term, but after second year, third year, it will be changes because we have to add something, add and multiply. In the second year, the maintenance cost is 600, and this gamma raised to n minus 1. N is equals to 2 means here 2 minus 1, that is equals to 1, means gamma, here gamma is 0.9. Therefore 0.9 raised to 1, it gives 0.9. Now multiply this 0.9 to this 600, we get 540. Now we add this 540 to this 5000 to get the total sum, and it gives 1040. Then we add this summation by cost of the machine. Cost of machine is 3000, and we add here 1040. We get 4040. Then we have to find out this summation gamma raised to n minus 1. Here it is 1. We have to add the second year's gamma raised to n is 0.9. So here we get 1.9. Now to find average cost, we have to divide this 4040 by 1.9. We get 2126.32. Obviously it will be decreased value. So we come to the third year. In the third year, the maintenance cost is 800 and n is equals to 3. Therefore 3 minus 1, that is equals to 2. That means to find this value in the third year, we have to find 0.9 raised to 2. The value of 0.9 raised to 2 is 0.81. Now we multiply this 0.81 to 800. Total we get 648. Now we add this 648 to this 1040. Total we get 1688.0. Now we add cost of the machine to this summation. We get 4688. Now we have to find out the summation of gamma raised to n minus 1. Here gamma raised to n minus 1, value of gamma raised to n minus 1 in the third year is 0.81. We have to add this 0.81 to this 1.90. We get 2.71. Then to find the average cost in the third year, we divide this 4688 by 2.71. We get the value 1729.89. Again it will be decreasing value. So we come to the fourth year. In the fourth year, the maintenance cost is, or running cost is 1000. To find gamma raised to n minus 1 in the fourth year, Here n is equals to 4, so here it is 4 minus 1, that is equals to 3. So gamma is 0.9, therefore 0.9 raised to 3. The value of 0.9 raised to 3 is 0.7290. Now we multiply it by 1000, so we get 729. Now we add this 729 to 1688, we get 2417. Then we add here cost of the machine to this, we get total year total cost up to 4th year is 5417. Then value of gamma raised, sum of value of gamma raised to n minus 1. Here it is 0.7290. We have to add this value to 2.71. We get the total sum as 3.4390. To find the average cost, we have to divide 5417 by 3.4390, and then we get 1575.17. As you watch this video, if possible, calculate these values simultaneously as you're working. So you get the clear idea and you can find out these values are true or false. All these values are true, I will calculate this. So just confirm it yourself by applying actual calculations. As here proceed further. If we observe this last value, again obviously it will be decreasing value. So we come to the 5th year. The running cost for the 5th year is 1300. The gamma raised to n minus 1, here n is again 5. N is here 5 minus 1, that is equals to 4. 0.9 raised to 4. Their value of 0.9 raised to 4 is 0.6561. We multiply this value to 1300, we get 852.93. We add this value to this 2417, we get 3269.93. Then we add this value to the cost of the machine, so we get the value total expenditure up to 5 years is 6269.93. Then summation of gamma raised to n minus 1 when n is equals to 5. For n is equals to 5, we add this 0.6561 to 3.4390, we get 4.0951. Then to find the average cost, we have to divide this 6269.93 by 4.0951. So we get 1531.08. Again, if you observe, this value is also decreasing value. So we come to the next year. Next year maintenance cost is 1600. So then we have to calculate gamma raised to n minus 1. Here gamma is 0.9, n is equals to 6. 6 minus 1 is 5. So 0.9 raised to 5, we get 0.5905. We multiply it by 1600, so we get Rn into gamma raised to n minus 1 as 944.78. Now we add this value to 3269.93, we get 4214.71. Then we add this value to a cost of the machine, so we get 7214.71. Then to find sum of gamma raised to n minus 1 for n is equals to 6, we add this 0.5905 to 4.90951, we get 4.6856. To find average cost at the 6th year, we divide 7214.71 by 4.6856, we get 1539.77. Now, observe these last two values. If we observe these last two values, now average cost will starts increasing after in the sixth year. So we can replace the machine at the end of the fifth year. Also, if we observe the maintenance cost for fifth year, average cost for fifth year and maintenance cost for the sixth year, we have here maintenance cost at the sixth year is 1600 and the average cost is 1531.08. So maintenance cost will also greater than this average cost. So we replace the machine at the end of fifth year. Now just conclude this statement and complete the problem. From above table, it is clear that now in this expression one mistake is there. Here it is f5 divided by summation I varies from 1 to 5 gamma raised to I minus 1. Here I have just by printing mistake, here it is 6, but in this problem here it is 5, not 6. Remaining 5 and 6 will be the same. R5 is less than f5 divided by summation I varies from 1 to 5 gamma raised to I minus 1 less than R6. Just take this mistake. Here we have to take replace this 6 by 5 by printing. There will be a mistake. So we get the values. The value of R5 is 1300. This average cost is 1531.08 and this running cost at the sixth year is 1600. So we can mention it total conclude statement. Hence it will be economical to replace the machine by a new one after fifth year, and weighted average for fifth year is given by x2 is equals to 1531.08. That completes the problem. We solve one more problem corresponding to this. The cost of the new machine is rupees 5000. The maintenance cost of the nth year is given by Rn is equals to 500 into n minus 1, where n varies from 1 to 3 and so on. Continue. Assume that the discounted rate per year is 0.5. After how many years it will be economical to replace the machine by new one? These are the given terms. Here we cannot get directly the maintenance cost or running cost. It is given in the form of a function. In the form a function n. Form of function in n. That we have to mention here. Rn is equals to 500 into n minus 1. N varies from 1 to 3 and so on. And we have to given the discounted rate, that is 0.5. So now first write down the given terms. Here the cost of the machine C is equals to rupees 5000 and discounted rate per year gamma is equals to 0.5. And this Rn, the maintenance cost is given by the relation Rn is equals to 500 into n minus 1, n varies from 1 to 3 and so on. And we compute the table as follows. The table is similar to previous one, just changes in the some values, and remaining part will be the same. There are 8 columns which we have to mention here. For our terms, we have to point out here up to 7th year's calculation. If we require for 8, we can extend this table and we have to find out the values corresponding to the 8th year. First we have to fill up this table up to 7th year, and then we come to the if required we have to come to 8th year. Start filling this table. In the previous example, we have to given directly the maintenance costs. per year. But here we cannot get the maintenance cost per year, but they are related to this relation. So we count the maintenance cost as per terms. For first year, means when n is equals to 1. When n is equals to 1, 1 minus 1 is 0, and 0 multiplied by 500 means maintenance cost is 0. Then gamma raised to n minus 1, again n is equals to 1, 1 minus 1 is 0, something raised to 0 is equals to 1. So this value will be the 1. Then multiplication of these two, which we have to require here, that is equals to again 0, because 0 multiplied by something is 0. Then we have to add up this there at the first value, and so it will be remains as it is. Then we have to add it the cost of the machine. The cost of machine is the 5000, so 5000 is as it is, because this summation value in the first case it will be 0. Then gamma raised to n minus 1, again it is equals to 1, it is the first value, and division of this to find out the average cost, that will be the 5000. In the first row, some points are obvious and that will be clear out here. Now come to the second year, when n is equals to 2. When n is equals to 2, 2 minus 1, that is equals to 1. 1 into 500 means the maintenance cost in the second year is up to 500. Then gamma raised to n minus 1. Here gamma is 0.5 and n is equals to 2. 2 minus 1, that is equals to 1, that is 0.5 raised to 1, that gives the value 0.5. Then multiplication of these two values, 500 into 0.5, it gives 250. Now we add this 250 to this 0, we get 250. Then we add here the cost of the machine. Cost of machine is 500. We have to add that 500 to 250. We get 5250. 5250. Then this sum of gamma raised to n minus 1. Here it is 1 and here it is 0.5. So addition of these two, 0.5 plus 1, that is 1.5. Then to find the average cost, we have to divide 5250 by 1.5 and we get 3500. Again it will be decreasing value. Come to the third year, when n is equals to 3. When n is equals to 3, 3 minus 1, that is equals to 2. 2 into 500, that is equals to 1000. Then gamma raised to n minus 1, n is equals to 3. 3 minus 1, that is equals to 2. Gamma is 0.5, therefore 0.5 raised to 2, it is equals to 0.25. Now we multiply this 0.25 to this 1000, we get 250. We add this 250 to this 250, we get 500. Then we add here cost of the machine, that is 5000, to this 500, we get 5500. Then to find sum of gamma raised to n minus 1, here it is 0.25, we add it to 1.50, we get 1.75. To find average cost, we have to divide this 5500 by 1.75. We get 3142.86. Again it will be decreasing value. So we come to the fourth year, when n is equals to 4. 4 minus 1, that is equals to 3. 3 into 500, that is equals to 1500. Then gamma is 0.5, n is equals to 4. 4 minus 1 is 3. Therefore 0.5 raised to 3, we get 0.125. 0.125. We multiply this 0.125 into 1500, we get 187.50. 187.50. We add it to this 500, we get 687.50. Then we add it the cost of machine, that is 5000, we get 5687.50. Then to find this gamma raised to n minus 1, here it is 0.125. We add it to 1.75. So we get 1.8750. Then to find the average cost at the end of the fourth year, we divide this 5687.50 by 1.8750. 1.8750. We get 3033.33. That will be the average cost in the fourth year. For fifth year, n is equals to 5. 5 minus 1 is 4. 4 into 500, it gives 2000. Then to find this gamma raised to n minus 1, gamma is 0.5. N is equals to 5. 5 minus 1 is 4. Therefore, 0.5 raised to 4, it gives 0.0625. Then we multiply it by 2000. So we get Rn into gamma raised to n minus 1. We get 125. We add this 125 to this 687.50 and 125, we get 812.50. Then we add cost of the machine to this 812.50. We get 5812.50. Then sum of gamma raised to n minus 1 means we have to add this 0.0625 to 1.8750. We get 1.9375. To find average cost at the end of fifth year, we divide this 5812.50 by 1.9375. We get 3000. Again, obviously, it will be decreasing value. So we come to the next, that is for sixth year. For n is equals to 6, 6 minus 1 is 5, 5 into 500, that is 2500. Then gamma is 0.5, n is 6, 6 minus 1 is 5, therefore 0.5 raised to 5, it gives 0.0313. We multiply it by 2500, so we get 78.13. Then we add this 78.13 to this 812.50. So we get 890.63. It is the summation Rn gamma raised to n minus 1 up when n is equals to 6. Now we add it by 5000, that is cost of the machine. We get total 5890.63. That will be the total cost for sixth year. Then to find this summation gamma raised to n minus 1, here it is 0.0313. We add it to 1.9375. We get 1.9688. Then to find the average cost for the sixth year, we divide this 5890.63 by 1.9688. We get 2992.06. Again, it will be decreasing value. So we come to the seventh year. That is for n is equals to 7. For n is equals to 7, 7 minus 1 is 6. 6 into 500, it gives 3000. Then gamma is 0.5, n is 7. 7 minus 1 is 6. 0.5 raised to 6. Value of 0.5 raised to 6 is 0.0156. We multiply it by 3000. So we get 46.88. We add it to 890.63. We get 937.50. Then we add it the cost of the machine. We get 5937.50. Then to find this summation gamma raised to n minus 1, we add this 0.0156 to 1.9688. So we get 1.9844. Then to find the average cost in the 7th year, we divide this 5937.50 by 1.9844. We get the value 2992.13. Now if we observe, then it starts increasing. The average cost will starts increasing. Just observe these last two values. For 6th year it is 2992.6.06, and for 7th year 2992.13. So it starts increasing. So we replace the machine at the end of this 6th year. Also, if we observe, the maintenance cost at the 7th year is 3000, and the average cost for the 6th year is 2992.06. This average cost for the 6th year is less than the maintenance cost of the 7th year, that is 3000. So we replace the machine at the end of 6th year. Just we conclude the point. From above table, it is clear that. Now it will be clear. This is correct. No any correction in this formulation. R6 is less than F6 divided by summation I varies from 1 to 6 gamma raised to I minus 1 less than R7. The value of R6 is 2500. This average cost for the 6th year is 2992.06, and which is less than 3000, that is maintenance cost in the 7th year. Hence, it will be economical to replace the machine by new one after 6th year, and weighted average for the 6th year is given by x2 is equals to 2992.06. That completes the examples. These are the two important examples which are taken from these reference books. Thank you for watching this video and having patience to watch this video. Thank you.